Yet again, welcome everyone to today's webinar on certification in bio-based construction. Today's event is hosted by two EU-funded research projects called BioReCer and RECO. And my name is Dušica Banduka. I'm from the nova-Institut. And in both of these projects, we are responsible for the communication and dissemination, but also for the development of novel policy recommendations and also guidelines. We are an independent consultancy and also supporting our clients in their transition to renewable carbon solutions. I would like to give you a short introduction to both projects, first starting with BioReCer. Here the goal is to assess and complement current certification schemes for biological waste feedstock, and we will develop a digital support tool to enhance tracking and traceability. The project includes a stakeholder platform, and here we kindly invite you to join, as we will have in August, most likely, our final stakeholder event. This will take place online, and also it's accessible to everyone who's registered. The 3CO project is looking at concise consumer communication and also aims to develop robust labels for bio-based systems. We aim to influence consumer behavior through smart digital tools, and therefore we will develop an application and also develop guidelines for labeling and label design, especially to support certification scheme holders. And as we are also planning future episodes of these webinar series, please subscribe to our newsletter to stay updated. Today, we are kindly joined by three international experts. One of them is Martin Behrens from the German Fachagentur für nachwachsende Rohstoffe. It's the German Agency for Renewable Materials. We have Sergei Kovalenkov, who is the CEO of Hempire. And we also have Hein van Tuyl, whose last name I most likely butchered again, from EPA Benelux. And we are also already set up the next webinar series where we will introduce some digital solutions developed in different EU research projects, also aiming to foster the EU bioeconomy on April 8th. So a little bit of housekeeping for today. You can see in the menu line that we have the Q&A section open, so please post your questions in the Q&A, not in the chat. And also, in case you would like to voice a statement verbally, you can just raise your hand and we will unmute you so you can speak up. And if you would like to state a question, please address it at the specific speaker. And also, all materials of today's webinar will be made available afterwards on the project website, so please stay tuned. And my colleague Anke, who is working with me in both projects, will introduce our first speaker for today.
Yes, exactly. So our first speaker is Martin Behrens. So Dušica, I must say you butchered his name, not the one from Hein. So it's Martin Behrens. He is an external advisory board member of the project 3CO. And it's fantastic to have him here today as a speaker for both projects. So Martin is a political scientist with specialization in European public administration and environmental science. He has experience in governance, sustainable rural and urban development, and environmental studies. At the Agency for Renewable Resources, in German that's Fachagentur nachwachsende Rohstoffe, I will say FNR from now on. So in FNR, he works as a senior advisor and is responsible for the development of and the supervision of EU projects, specialized in multi-stakeholder activities in the bioeconomy. Additionally, he is in charge of networking activities within FNR's Department for EU and International Affairs. And he is and was involved in EU and R&I projects and is a member in various advisory boards. So, Martin, the stage is yours.
Good afternoon, everyone. Could you just refresh my memory? How much time do you have?
You have 20 minutes.
20 minutes. Okay, good. So that's what I planned for. That's fine. So good afternoon, everyone. I will start sharing my screen. Okay, can you see it?
Looks good. Perfect.
All right, perfect. Okay. Yes. Well, you heard what I'm usually working on, and I must say, well, I'm an expert in many fields, but not necessarily on sustainability certification in construction. However, I'm working a lot with related topics, also on construction, on bio-based products, and building with timber in different working groups. So I have heard about this, and of course I'm familiar with some of the schemes. So what I can give you today, just to have a bit of an expectation management, is an overview. But if you are really eager to dive into the details, I'm afraid I'm not the right person to answer your questions, but let's see. So let's look into this. I'm going to give you an overview on, well, basically on the different construction products. And then I separated between certification on specific products and on the entire building system, two different things and different schemes. So let's dive into it. So mouse is not working. Okay, let's do it. Okay, good. A few words about my Agency for Renewable Resources. We are a public agency under the Ministry of Food and Agriculture and around for quite a few years now. Working entirely on the bioeconomy, except food and feed, although it's changing. But that's basically our expertise. And in this capacity, we are mainly involved in financing research and innovation projects on the national level in the different sectors and areas of the bio-based economy. And because we finance research, we of course also talk a lot about results. And are eager to inform the different stakeholder groups, constituencies about what's new and the most recent developments in different fields. When it comes to the topic of today, we are also quite active in the field of construction with different publications. I'm afraid most of them are in German, but of course, Google Translator or similar systems will help you to dive into it. There are also different kinds of websites where you can have a look. If you're interested, just have a look at our different services. And we also offer consultancy is not the right word, maybe advisory service for builders, for architects, if they want to learn more about construction with bio-based products and timber. Yes, as I said before, I would like to go into 3 different fields. I would start with an overview about construction products. Then we can have a look at certification specific for an individual product, and last but not least, into the entire building system. Since there are many products, I took the liberty to focus on one and then give you an overview about the others. So I would like to give you some details about bio-based insulation materials and the most common properties when it comes to these materials. There's also this nice picture of one publication we have at FNR if you want to learn more about this. Yes, when it comes to insulation materials, there are various issues quite relevant and interesting. One is circularity. Insulation materials made from renewable raw materials can often be recycled. They can be reused as new insulation materials, as raw materials for other products. And in the final step, as a raw material for pollutant-free energy generation. So actually there are no waste residues. And that's, of course, a big difference when you compare it with mineral wool, one quite common insulation material, which is still almost entirely disposed in landfills. And polystyrene is also not a good example when it comes to circularity. One other aspect is, of course, resource protection. Natural fiber insulation materials are considered the raw material source of the future in building construction, especially when it comes to climate change. And we all want to reduce the use of fossil resources, fossil fuels, also in construction, which is one of the main emitters of CO2 emissions worldwide. So quite a lot to do here, especially when it comes to the different materials we use. So another aspect is CO2 storage. So if you build with long-lasting materials which are bio-based, you can also, of course, save carbon for long term. Durability is an issue. The use of natural fiber insulation in timber construction enhances the robustness and safety of the structure. Quite interesting for builders is the thermal storage capacity, capability. So there is this famous buffering effect of the materials, which is significant. They absorb peak temperatures, and this is particularly effective with large quantities of materials, of course. So, of course, always when you look into materials, there are advantages and disadvantages, and basically you need to, to look at what you want to do, what kind of properties and functionalities you need, and then do the comparison. But that's not different from any other material, which no matter whether it is fossil or bio-based. So that's something you always need to do, of course. Okay, just a quick overview on other materials in insulation, flax, hemp, wood fiber, sheep wool, cellulose. So there are all kinds of options. Some are more common, some are less common. And again, some advertisement to have a look at this brochure we published to learn more about this. Now let's look into other construction products, and I'm trying to be quick here. So we have, of course, similar issues like like with the insulation materials. So the thermal behavior is quite interesting, the moisture behavior. Toxic load is and can be an issue because you sometimes have very nice nature-based, bio-based materials which are then somehow mixed or enhanced, see my hands and air quote, with toxic materials. So it's good to examine what's in your product, and even if it is bio-based, it can be harmful because some other substances are used. The same is an issue with odor. And of course, all materials used in indoors should either have a pleasant smell, and then that can be, of course, different from person to person, or should be odor neutral. When it comes to fire behavior, that's quite an important point and often stressed. And there are a lot of questions about this in the construction sector. The main key message is that natural building materials often are basically more predictable when it comes to fire behavior, because you don't have too many material mixes as you have in other construction with other construction products. And so you can predict the behavior in a situation of fire. And secondly, they are often less toxic. So that's also important, because people usually do not get injured or die because of the fire, but because of the toxic smokes and gases. So that's the thing where you really need to look into, because it is in the end about saving lives, right? But again, yeah, fire is something you can have in every building, no matter what kind of material you use. Okay. Somehow my mouse is not always working. Now it's again. Okay, just to give you a quick view on other areas where you can use Biobased products, and then I go into the certification. Flooring, wood windows, furniture, paints, coatings, all interior walls and surfaces. Again, a brochure for you to have a look. Let's have a quick dive into construction certification, construction product certification. A few examples here are specifically on certain product categories, and then it gets a bit wider, and you see that along the way. So of course, quite famous is the German Blue Angel. Might be small, so maybe something for you to study later. But there are multiple different areas where you have a sustainability certification here with clear criteria. They can be used in public procurement cases if you are a public buyer. So it's really an interesting area to look into when it comes to product-specific certification. Second is Nature Plus label, an eco-label, which is not only available in Germany, but also in other parts of Europe. It's recognized by leading certification teams in Europe and international, actually. So it is also used for certification of entire building systems. And Nature Plus covers criteria including climate protection, healthy living, and the resource conservation. And you have a link here always, so you can dive into the details. This one is, well, in Germany, Holz von here. It's a low carbon timber certification. It is a specific scheme which focuses on the material base, timber, yeah, and it is a type 1 label. And the criteria cover the entire transport along the value chain, which is quite important because that's where you have the carbon. If you look at the entire product value chain, that's where you create the most carbon, the transport of the wood. And of course, that's something you really should look into when you want to build with timber in a sustainable way. It all covers FSC or PFC or similar standards when it comes to sustainable forest management systems. But what's important here that these tracking of the transport. So that's quite interesting. A few other examples are these building passport of a German certification system on sustainable construction, which is also looking into the different materials used. So this will be coming also as an example in a different scheme later when it comes to entire buildings. And last but not least, there is, well, this is not a certification scheme, but this is if you want to really go into the details of specific products, it is quite important that you have the data for that. And this platform, ÖkoBau database provides that. It is it was established by the Federal Ministry for Housing, Urban Development and Building, and it's an online database which basically has data sets for LCA for more than 1,400 different building products. So you can also make the comparison maybe between fossil-based, bio-based, etc. So quite a good tool to dive into. All right, now let's have a look into sustainability schemes for entire buildings. So I'm focusing here on the federal support schemes, schemes which are basically backed up by the German government. And well, why do we have that? Because there's an increasing demand for these kind of buildings, and yeah, the need to back this up with a clear certification system backed up by clear data and science. So that's what I'm going to show you now. So the one certification scheme is again a certification scheme by organized by the Federal Ministry of Housing, Urban Development and Buildings. And it is basically using existing schemes in Germany, somehow mashing them up and combining them. It's quite new and has been recently still be in discussion when it comes to some of the details. But it is basically providing standards for residential and non-residential buildings, including newly constructed and refurbished buildings. So it also looks into refurbishment, renovation. What the beauty here is that we have a couple of certification institutes available in Germany, and they do the certification along this scheme. And so it's quite a nice thing here. This one is a more traditional one. It's it has been around for quite a while now, well, it's basically a sustainability certification for buildings and construction products, so it covers both sides. And criteria look into the environmental, social, and economic criteria, including LCAs and also resource efficient design. So how can we build with less? Quite important. And they are different standards. Of course, there's always this high standard, but you can also go below that and still build in a sustainable way. So quite interesting, again, link. So if you want to dive into it, there's always also information available in English at these sources. So quite nice also if you are not familiar with the German language. And this is the last example I would like to show you. And basically all these 3 examples I just presented, they are interchangeable, they are interlinked, they also referencing each other's standards in their systems. So it's a nice way. You don't need to reinvent the wheel here. So they are relying on existing standards and ways how to measure and evaluate the sustainability for performance of a building. So this one provides measurable and verifiable criteria for the evaluation of construction measures based on economic, social, cultural, and functional technical processes. So again, we have different levels, different standards from gold standard, silver, and bronze standard. And also quite interesting is that there are differences between the type of building we are looking at. So you have the possibility to get this standard for different buildings in education, laboratory buildings, outdoor facilities. What's maybe the difference here is this one is, well, I think this one as well, you get it afterwards, right? You build your building and then you get the certification, maybe as an advertisement or really to show what you have done here. So that's it from my side as an overview. Thank you very much. And well, let's see if I can answer your questions in the chat. Thank you.
Thank you very much, Martin. Yes, there are already some questions in the chat, and we will answer them at the very end of the webinar.
Okay.
And I would like to welcome our next speaker, who is Sergey Kovalenko. He is the founder and CEO of Hempire and a leading expert in the field of hemp building with over 14 years of experience. He founded Hempire UA, developing the innovative fifth element, which is a binder for carbon-negative hemp line insulation. Sergey has extensive knowledge in energy efficiency and green building practices, but is also a frequent speaker at international conferences. He's also a co-founder of the US Hemp Building Association and currently involved in building the largest hemp residential complex in Western Ukraine, which will host refugees and orphans in the near future. This is done in the framework of the non-profit organization Hemp Ukraine Recover. Thank you so much for joining us, Sergey, at 5 a.m. in the morning.
Good day, everyone. Yeah, I'm joining you from Colorado, where we are actually building a first ever stargazing center using industrial hemp. So basically, it's going to be first one of a kind, an observatory and 20 villas where you can be looking at the stars while we're going to be using local materials. So whoever is interested, I'm going to show some photos, obviously, about this project during my presentation. So it's an interesting way of building it. It's called Cosmos, by the way, the Stargazing Center. But anyways, we'll go one step at a time. I'm a big fan of bio-based materials, and thank you for inviting me. I'm a civil engineer by trade, and I've been involved in construction industry my whole life. But ever since I got introduced to industrial hemp and all aspects of it, I have to say my life changed drastically, and I hope I would be able to, change yours, by showcasing what we have done. Basically, I'm just going to share my screen right now. This is Hempire, our company, and we've been involved in the hemp building over the last 10 years in Ukraine. I've been doing it for 15 years all around the world. And I have to say that we come to the point where we need bio-based materials badly. And Ukraine is one of the best examples to showcase it. And of course, I would like to start with the slide that just kind of portrays what we've been involved in, and of course the right-hand side is actually a better understanding what is truly happening around the world, especially in the construction industry, where 40% of all carbon emissions fall down on the construction industry, not because it takes a lot of energy to manufacture these products, but it's actually maintenance of the buildings where, the largest chunk of all the carbon emissions happen. So first we produce extremely energy inefficient materials, and then we need to heat up those buildings somehow. We need to cool them down or maintain them a certain way, and we use a lot of energy, which is highly inefficient. It creates a lot of health issues. It creates a lot of carbon emissions if you need to replace them once in a while, after 25, 30 years. And of course, I travel a lot around the world, and I have to tell you that we have a massive housing shortage. And, there's a big, there's a big false agenda on the exponential growth. How can we have an exponential growth when we have limited amount of resources on the planet? So obviously we need to use renewable ones, bio-based, and hemp is definitely one of the answers. And Europe has always been cultivating hemp hundreds of years ago, and now we're coming back to realization that we need these bio-based materials really back. And of course, by introducing flax based materials, bio-based materials, so we're talking about the rice husks, we're talking about the corn, sugarcane, and different, coconut fiber. For example, in some of the Latin countries, what we have seen showing an incredible possibilities. For example, on this slide, you see all of these products are made out of hemp, hemp fiber insulation, flooring board made out of hemp and natural glues, a popcorn, basically a corn-based insulation surrounded by the composite panels made out of hemp fiber, and of course the hemp line blocks. So all of these things that you see right now are as a product of one single plant. And of course, it has nothing to do with the CBD cannabis plant. It's an industrial crop. Here is an image of me standing in Australia about 15 years ago, where we were witnessing how the harvester, just like puts it down onto the ground, cuts the crop that grows literally within 90 days. Then they leave it in the field, of course, to ret and to dry up. And then later on, this biomass gets baled up and brought into the decortication facility, where the machines are splitting the hurd, the inner core particle of the hemp stem from the fiber. So the fiber will go towards paper industry, textile industry, biocomposite industry, and the inner core particles we are successfully using as an insulation. And I'm sure many of you already heard about the product called hempcrete, hemp lime. And so these little particles, they basically become an incredible filler because it contains a lot of air, and we're mixing it up with the lime-based binder that consists only natural ingredients, including lime and minerals. It does not include any cement or any toxic components. And we are mixing it with water. So inside the insulation, there are only 3 ingredients. And what I love about this system is that we can insulate any type of insulation. We can insulate. Sorry, it's 5 a.m. here. We can insulate any type of surface inside the home with these 3 ingredients, which is quite remarkable, right? Think about all the products that construction industry is currently enforcing architects and builders to use, where we can replace them with one single material. It's quite remarkable. And I have to say that the interest towards bio-based material is raising. I was one of the founders of USA Hemp Building Association. We formed this association in 2019, and in the last 5 years, we have been educating ASTM engineers and actually spending our own money and raising the capital to finally get it introduced into the international residential code. Now, since January 1st, 2024, officially, hemp lime has been included into the IRC database. So now all the architects from all around the world can come in and review this type of product, which is now on the website of the ICC, International Code Council. So International Code Council is the one that is responsible for providing recommendations of the products that can be included into the either residential construction or commercial construction. So this one in particular, this material now is officially in the IRC, International Residential Code. So now the architects, whenever they design the house or the low-rise house, so we're talking about 2 stories high residential homes, now they can officially include this material in their design project. It's a huge, huge victory. The same path was followed after the straw bale insulation was introduced. So it has a massive, massive potential. It's an incredible product. And like I've said, I will show you right now many photos how this material has been used over the years by us on different construction projects. So basically, once you mix up all these components, you have your timber frame or steel frame or concrete frame even, and we can go around and we can install this material all around your load-bearing elements. So you can spray this material. That's also part of our work in the ICC coding. So now it's official that you can spray it against timber frame. There are blocks right now that has been developed by the companies, like in France, for example. It's a BioReCer block introduced by VCAT, as you can see right here. Then there is non-load bearing blocks that can be included using timber frame elements. Then there is prefabricated panels. This company is called Danagro, good friends of ours located in Holland. So as you can see, there are already companies inside the European Union that have been actively using bio-based materials in order to create an incredibly energy efficient housing. One of my favorite systems that we would like to use is, of course, the on-site casting. As you can see, with on-site casting, you can have your load-bearing elements completely or partially covered by the biomass. That, by the way, once we install, it is cured by absorbing carbon dioxide from the atmosphere, and it turns into the light stone, which is 9 times lighter, 8 to 9 times lighter than concrete. As you can see, here is an example of a timber frame. Here we run the electrical cabling and all the plumbing right through the timber frame. We install the formwork. We compact it in layers 10 to 15 centimeters at a time. And as we get to the top of the formwork here, you can see that the timber frame is completely surrounded by this mortar. So that means there is no thermal bridging. And once we get to the top of the formwork, you can remove the formwork instantly and let the material cure and absorb carbon dioxide. So practically it's a carbon negative material, especially if you're sourcing your biomass locally. So when we founded Hempire and when the formulation was developed, there were two principles that we followed in the very beginning. It was supposed to be 100% natural, the formulation of the binder and the insulation overall, and it had to be 100% Ukrainian, meaning we would have to be independent from importation. And there were many people were telling me to cut corners in the very beginning, but I said, no, this is very important to source materials locally. And I have to be honest, that what has helped us to continue our projects during the pandemic and during the war. Right now, as we speak, we continue to build houses using the bio-based materials like this one, as you can see. And now people to realizing, that the logistical costs are going through the roof all around the world. So it is incredibly important to use local materials. So wherever you are, you always have to be sourcing local materials in order to keep it sustainable and of course financially feasible for the final client. So here you can see an example of this project. Once all the forms is removed, the hemp lime continues to sequester carbon dioxide, and lime is just turned into the limestone. In the end, it's just a bunch of limestone particles that including the practically wood chips. It's a biomass, right? So no one can tell you that these homes are built using industrial hemp. As you can see, there are examples of roofs and floors. And here you can see on the right hand slide, you can see even when we are insulating existing structures with this. So I'm just going to go through a bunch of photos just to show you the capabilities of this technology, which is very powerful. And we've been using it. I'll tell you, I travel all around the world, and the interest is only growing. Where 15 years ago, when I started my path in the bio-based construction um, industry, no one could care less about it. So it was a very difficult communication with architects, especially where they couldn't find a lot of information in regards to this product. But thanks to EIHA, for example, European Industrial Hemp Association, their conferences, their push towards using the bio-based materials, we see we see hemp industry rising all around the world, and now we're on a very good path to showcase to people, and especially the architects, since they are the ones taking responsibility and including these materials in the design projects. It was a battle 10, 15 years ago. Now things are, things are getting easier. But what I do, we go all around the world and we introduce these materials in different countries. As you can see here, this is a very good example where the lime plaster is used on the inside of the building, on the facade and on the interior, meaning that there is zero toxic components. It's 100% natural elements in the wall partition, which is quite powerful, that were locally sourced. And of course, we're not just talking about mud huts. This technology can be used for the modern looking buildings. It's not just, there's for sometimes people think that, yeah, these houses cannot look like a modern house, but no one can tell you that this house has been built using industrial hemp. So right now, for example, one of the main problems that we have with certifying these products in European Union, we have to receive a CE marking on all our products, meaning that our production facilities, they have to comply with all the European Union regulations. Unfortunately, it doesn't go vice versa. It is much easier to register European Union products inside Ukraine, and it takes up to I believe it takes up to 1 year to go through the entire certification process. If you would be looking to use European Union bio-based materials of similar origin, like we're talking about hemp lime in particular, where the Ukrainian products, it would take a passage of about 3 years to get all the testing done and introduce them onto European Union market. So that's the problem we're currently having, because we're very price competitive in terms of our binder, in terms of our hemp herds, but unfortunately, this these regulations are not letting us introduce our materials, at least to the Eastern European countries, like Hungary, Slovakia, Poland, etc. We don't want to move our product to Portugal and bring it on the truck for 5,000 kilometers. Uh, of course, but at the same time, yeah, we see that the certifying these products and introducing them into EU is it's a slow process. Unfortunately, I wish bureaucratic barriers would fall down, and European Union citizens would enjoy the bio-based solution-based materials more. For example, we have a project in Denmark, and it literally takes a year to design it, and it's a small building, it's a community building, 60 square meters. But the bureaucratical barriers is what creating all the problems. And I believe European Union needs to simplify these things. So, for example, we have colleagues producing materials in Germany, and they cannot sell it in Belgium, because Belgium, beside the EU building code, they have their own code, just like France. And what is the point of European Union when the products of one country produced inside one country, European Union, cannot be used in the other country? So those are the issues that should be that should be taken care of immediately, because it's slowing down the progress of bio-based materials in my idea. Here you can see that we leave this material in the Carpathian Mountains completely exposed to the to nature. Imagine if it would be basalt insulation or any type of synthetic fiber insulation left like this, exposed for the entire winter, somewhere in a humid, cold climate, it would become practically trash. Here we're just showcasing that the outside walls, the inner partitions, and interstitial space all insulated with one product. Here you see, of course, the examples of domes, more challenging ones. Another very important aspect, we need to understand that we are building homes for people. I understand that regulation and certification is very important, but in the end, that's the people that live inside these dwellings. So we have to make them as comfortable and cozy as possible, energy efficient as possible, but at the same time, we're not forgetting, about the environmental aspect. For the last century, no one cared about the environmental aspect of construction industry, and the health aspect. It's a taboo topic, totally. But I speak all around the world, from Japan to Hawaii, and I tell you that the health issues that people have living in the houses built out of toxic materials, it's a big issue that no one's raising, and it's a big problem. Here you can see the internal insulation. This is images taken in Ukraine. This is during the war. So we're turning an extremely ugly building into an incredibly energy efficient one, just by introducing these materials from inside. I'm going to be cutting it short soon, but just to show you, for example, our colleagues in Poland, they're cultivating industrial hemp for food grade products, and we organized a workshop. They purchased a hemp processing facility, hemp processing line, and we're using hemp grown in this field and processed and installed in this house. How incredible is this? Think about it. Think about the carbon footprint on this house. All the hemp that was grown there, we have processed and used in this beautiful dwelling. I just don't want to take up any of your time anymore. Obviously there are plasters. This is a concrete, old Soviet industrial concrete building where we turned it into the yoga studio by insulating the concrete walls when it was minus 15 degrees Celsius, at least at night. It was a frosty wall, unheated space, and now we have put hemp insulation on around dwelling just to make it an incredibly cozy yoga space. Just wanted to show you the stargazing center for you to admire. This is very, very interesting. By the way, these are all real houses. People live inside them. And they're incredibly grateful for what we have here. Is a Maui house. As you can see, we can build up all the internal partitions inside the homes using one single material, which is quite remarkable. Here is the stargazing center I want to show you. This is a homeopathic center in Oregon, where we organize back-to-back workshops, and we have used local manpower, saving $30,000 to $40,000 to the client in just inviting people over to learn how to build with hemp-based materials, which is an incredible story. And now it's the foundation of this. You can see this is a woodcrete blocks, so it means mineralized wood chives and mixed with cement, reducing the cement content in foundation by 30%, and using hemp lime insulation material. This is an old farm that we're turning into the residential complex during the war. Basically, we organized a workshop in the western part of Ukraine, and we were teaching the internally displaced people, or you can call them refugees in Ukraine. Unfortunately, that's how we have to kind of call them. And to build this is like the largest so far residential complex built out of hemp in modern Ukraine. We're raising funds for this project as well. So this is a stargazing center I told you about. We're building in the middle of Colorado. Basically, and there's going to be a villa. In each villa there will be telescopes. So, and we're using local bio-based hemp materials and to build this resort. As you can see, the first villas are coming up. And yeah, I don't want to talk about the advantages. Just to finalize, what I wanted to tell you is that we need to find ways to simplify certification of bio-based materials because, as you can see, we're teaching children how to do it because we're running out of time. And if the governments talk about the carbon agenda, the environmental aspects of our lifestyle, that we need to reduce the consumption of products, that we need to use, we need to be very conscious about how we consume things, then of course materials like this, it's pest resistant, mold resistant. We have projects in Thailand and Indonesia, Bali, where mold is a big issue. I know mold is a big issue in European countries as well during winter when it gets very humid and cold. And this material has shown to us that we need to use it more often. Um, I don't know, I can continue for 5 hours talking about this material because I'm a civil engineer, but simplifying things. I'll tell you very, very interesting one last aspect of it all. You have to understand that the testing, um, the entire certification procedure and the whole testing system is designed around synthetic based materials. Bio-based materials, they act differently, they work differently. So there has to be standards created to test products equally. So these products will be, so you're comparing apples to apples, not apples to oranges. So this material is an incredibly durable material, and it's a fire-resistant material. And of course, the different system of testing it and certifying has to be introduced inside European Union in order to move quickly, because the sky is the limit here. As I showed you an example in Poland, where we have used the biomass that has been grown, harvested in the field next door, processed in a facility, which is located a few hundred meters away, and you're just basically stuffing it into the walls, into the roofs of the building next door. It's a very powerful model. Thank you so much for your time. If you have any questions, here's my contacts, and I know people already showing it up, and that's I'm running out of time. So thank you very much. Yeah.
So thank you so much for this great overview and showing all these very impressive houses. I mean, making houses just from hemp is just a fantastic idea. So good luck with your ongoing projects.
Thank you so much.
So next speaker is Hein van Teuyen. He's from IPEA Benelux. I will start introducing IPEA before I start introducing Hein. IPEA is a pioneer in developing and applying materials passports and digital product passports in practice. Hein is the managing director of IPEA Benelux, and in this function, he coordinated the European Buildings as Materials Bank project that led the foundation for a European cross-sectoral standard for circularity data. A current ISO standard for the data structure was just launched. Within their cradle-to-cradle projects, IPEA applies passport solutions for buildings as well as products. So the floor is yours.
Thank you. And thanks for the kind invitation to tell a short story about who we are and what we do. Let me share my screen here. How much time do I have to speak? So I can take that
We're
into
still
account.
pretty much on schedule, Hein. You can take your 20
minutes. So in my presentation, I'd like to address three things. One is certification, primarily under the Cradle Certified standard. The second topic is communicating circularity data, which reaches into the domain of materials passports and digital product passports. And the third topic will be just to show you some practical examples from projects at the building level that we're involved in. There's a bit of history to my story, and I think it's relevant as a background. EPEA was founded in the 1980s as a research and consulting institute, and basically we do two things. One is we develop tools and methods to apply cradle-to-cradle thinking in practice. And the cradle-to-cradle design framework that we co-developed in the 1990s intends to create positive impacts for products, systems, and buildings. So it's a step beyond conventional sustainability approaches, where the intention under cradle-to-cradle is very clearly focused at realizing measurable positive impacts. And our second role is to apply the tools and methodologies in real-life cases. And we do so at the product level, starting with chemistry, all the way up to final products in the B2C markets as well as the B2B markets, and applying this thinking at the building level. So that's a lot to unpack, and you will see also by the examples that there's a nice red thread running through all of that work. Before I move on, my personal career at EPEA started in 2010. This was the year where two important things happened in our environment. One was that the cradle-to-cradle certification standard, which I will speak about a little bit later, was donated by to an independent non-profit organization who since then own and manage the cradle-to-cradle certified standard. And in that year, we started the training of the Ellen MacArthur Foundation together with McKinsey and Company, who used the trainings in cradle-to-cradle to write their reports named Towards the Circular Economy. So basically, the scientific background to the circular economy is cradle-to-cradle, and then the work of Ellen MacArthur Foundation focused on calculating and communicating the economic value potential of transitioning to a circular economy. Here are just some figures of our organization. I am responsible for the left side of this picture, meaning the Netherlands, Belgium, and Luxembourg. We're headquartered in Hamburg, Germany, and we've opened up offices in 3 other big cities in Germany as well as in Vienna. When we apply cradle-to-cradle to products and materials, we do so across industries. And that's actually very interesting because it allows us to integrate circular solutions from one industry into the other ones. So for instance, when we work with Carlsberg on improving their packaging, and for instance, we work on the improvement of the colorants, the inks, and the pigments, then a lot of that knowledge can actually be directly applied to building and construction materials or to textiles and fashion. So this allows us to scale up the innovation and optimization work that we do, and also to forge smart partnerships. Okay, the first topic that I wanted to address with you today is the Cradle-to-Cradle Certified Products Program, which is a multi-attribute cross-industry quality standard for the circular economy. and it's a certification program that focuses on products. So buildings are exempt from certification, foodstuffs are exempt, medicine are exempt, but what is included are consumer goods, building and construction materials, even chemicals like textile dyes, colorants, polymers. All of those can enter into this program, where they are being verified on a multitude of aspects, which I will dig in a little bit later. The Cradle to Cradle certified label is available internationally and worldwide. So my work focuses primarily on the European countries as well as North America. But there's also lots of certification holders in Asian and Latin American countries, for instance. And we see that the acceptance and the recognition of the label is mainly centered around European and North American markets. It's applicable across all industry sectors, as I already mentioned. It shows us a holistic approach, which I will explain in a little bit more detail. And as I mentioned during the introduction, it considers a positive definition of material health down to the substance level. What does that mean in practice? The certification scheme is owned and managed by the independent Cradle to Cradle Products Innovation Institute that has offices in Amsterdam, the Netherlands, as well as San Francisco, United States. And they have trained a range of accredited assessment bodies, EPEA being one of them, to help companies achieve Cradle to Cradle certification. So our task in this position is to work with clients in running them through a certification protocol, reporting our research findings to the Cradle to Cradle Products Innovation Institute, and they, upon approval, submit the certification directly to the product manufacturer. There are 3 types of certification under the Cradle to Cradle Certified program. In the center, you will see a logo for the full scope certification, and the full scope certification encompasses the 5 categories that are displayed in the ring around the full scope logo. 2 of those categories are related to the materials that are being used in the product. The first one is material health, meaning what is the impact of the materials that are being used in the product for people and for the environment in the context of production, use, and end of use. So this is a qualitative approach to environmental and human health, which is a crucial component of the cradle approach, because materials are either safe or toxic depending on context, exposure, volumes, dosage, use scenarios, etc. The second criterion that operates at the materials level is the product circularity criterion on the right-hand side, and this evaluates the circular economy potential and attributes of the material or the product. There are 3 pillars that make up the product circularity category that I will dig into a little bit later. And then there are 3 categories that evaluate the production process. And those are water and soil stewardship, clean air and climate protection, and social fairness. So you see that for a full scope certification, the approach is holistic. We look at everything from the chemical composition of the product and its impacts, all the way to how social fairness rights are being managed and protected in the supply chain. On the material health category, it is possible under the Cradle Certified program to get a certification on that category. It's called the Material Health Certificate, and it's primarily aimed at supply chain partners. So companies like AkzoNobel or Dystar or Eastman, SABIC, These types of companies frequently sit at the start of the supply chain for many product manufacturers, and the Material Health Certificate program allows them to have a third-party verification on the material health properties of the chemicals that will be used in products later on. If a product manufacturer uses materials that are already certified under the Material Health Program, then the work doesn't need to be redone when they pursue cradle-to-cradle certification. So there's a clear incentive for cradle-to-cradle certification holders to source materials from the market that are already material health certified, and vice versa. There's a clear incentive for chemicals manufacturers to provide material health certified chemicals and materials into the market, because they can be easily used by companies that seek certification under the cradle-to-cradle standard. On the right-hand side, we see the product circularity category. And also there, it is possible to have a product certified under the C2C circularity certification. And this certification program looks at the product circularity category in isolation, and it's primarily aimed at innovative startups that focus on developing circular economy solutions, so they can have a low-level entry and third-party verification of their circularity claims. And it's also targeting the more manifested companies that want to develop specific products with outstanding circularity properties. So new innovations for existing bigger companies. Now we will look a little bit more into detail into the requirements that are related to each of these certifications. On the vertical axis, you can see the 5 categories that I've just very briefly explained. And then on the horizontal axis in this graph, you can see the levels of performance. Companies entering the full scope certification will be evaluated on each of these categories, and they will also be ranked on each of these categories. So the performance rating will always have to be bronze, silver, gold, or platinum. And the overall certification level that can be achieved is the lowest performance level on an individual category. So in theory, it is possible for an applicant to perform at the platinum level on 4 out of 5 categories, and bronze on the 5th, and then their overall certification level will be bronze. The general requirements section is basically an entry-level requirement where the protocol requires applicants to have a minimum of sustainability reporting, public sustainability reporting already in place. So the program is not open to any company who doesn't have any work on the broader topic of sustainability not already in place. Let's see if I can show you this exactly. So full certificate is the green bar. You have to perform well under all of the certification categories. The material health certification is the blue bar. You need to meet the general requirements, and then you will be ranked on the material health requirements. And then the red bar shows the circularity certificate, which is primarily focused on product circularity, but it also puts a minimum of requirements under the material health category. And it also means that the general requirements need to be fulfilled for all of these certification holders. Material health is basically our approach to defining the suitability of materials to enter into circular systems. So the way we approach it is to peel off the layers of any product, assuming that the product in application is a bottle of detergent. Then we would want to know not only the chemical formulations of the detergents, but also of the packaging. So first we look at the individual homogeneous materials, And then we look at the level of the chemicals, which is basically the domain of the tier 2, 3, or farther back supply chain partners. And the reason why we start there is because we want to make sure that materials entering the circular economy are actually safe for people and for the environment and can be managed proactively through their respective cycles in the circular economy. The methodology we use for that evaluation is the ABCX assessment, which is qualitative in nature, meaning that an aluminium in a building facade could be evaluated as positive because the impact on human and environmental health is okay. The material can be recovered and be recycled at very high levels of quality. And so in this use case, the material could get a positive rating. In another scenario where we would find an aluminium, for instance, in a cosmetics product, we have to assume that the aluminium can actually enter the human body, where it is a known neurotoxin, and there the same material might get a negative rating under this assessment methodology. So it's not a generalistic approach. It's very specific to the exposure scenarios and the use case that the manufacturer has in mind for the products. And it also allows the product manufacturer to go through a process of continuous improvement, meaning getting rid of all the X-rated chemicals and replacing them with more positively defined chemistry. I basically left this slide in because I know the slides will be shared, but I will not go into it in much detail now. But these are the requirements in a nutshell for you to have a look at later, should you be interested. The second category I wanted to highlight, the second and final category I wanted to highlight for the certification is product circularity, which intends to evaluate both materials for biological cycles, as were already mentioned in some of the previous presentations, as well as materials that will flow in what we call technical cycles. The three pillars that carry the product circularity category are circular sourcing. This appeals to all of the materials that are being used and their circular aspects, meaning are they recycled or are they renewably sourced? The second pillar is circular design, meaning how does the product design facilitate circular use or circular recovery of the individual materials? So this is where design for disassembly comes into play. And the third pillar is circular systems. To what extent is there already an infrastructure for the actual circular use of these materials and products? These are the three color codes I've used for the next slide. So you can see that under the Cradle to Cradle program, there's an incremental improvement requirement. So at the bronze level, the percentage of materials that are compatible with the intended cycling pathway is 50%, but at platinum level, it is 99% or more. Similarly, for the circular sourcing category, at the bronze level, there needs to be a minimum of cycled and/or renewable content, and at the platinum level, there has to be a technically feasible maximum achieved. There are lots of guidance documents under the certification standard that help us define what is a technically feasible minimum or maximum for a specific product in a specific industry. And I'm happy to dig into more details about this specific topic, should you be interested. The third pillar is the the circular systems, where the requirements are that the product is actively being cycled and that circularity data is publicly made available for all of these stakeholders in the circular material flow. Let's see, I should speed up a little bit. So I will go to an example to show you how circular design actually informs circularity. using the example of a solar panel. When we look at this solar panel at the level of the individual homogeneous materials, we could say that actually a lot of them are fairly to very well positioned for circularity. For instance, a frame might be made of aluminium. A glass panel could go into high-level recycling. There's lots of technology being developed for the recycling of the PV cells. But when we look at the final product, we have to notice that actually all of these layers are laminated or glued together, and they're almost impossible to recover into their homogeneous material streams. And so it sort of destroys, the product design destroys the potential for circular use of the individual materials. So this is the type of challenge we want to address and solve using the program. The bridge to the next topic is the circularity data report and cycling instructions requirement. If we want to move from a linear economy that does a little bit of recycling to a truly circular economy, then it's absolutely important that information about the circular potential of materials and products travels with the product to the next stakeholder, so that this circular potential can actually be activated. And so the requirement under the Cradle certification standard basically forces all of these industry partners to start sharing this type of data. And it's an important aspect of the circular economy that EPEA has been working on next to the certification protocol for many years. So in 2010, our group published a scientific study about the necessity for materials passports in achieving a circular economy. The article is still online at the Springer Encyclopedia. It's called Materials Banking and Resource Repletion, the Role of Buildings and Materials Passports. And the way we define these materials passports are sets of data describing defined characteristics of materials and products that give them value for recovery and reuse. And we started applying these materials passports to light systems, to ships, to building projects, even to city lighting projects. And by doing so, we noticed that in each of these projects, we were getting a lot of good results from sharing circularity data in the stakeholder groups within those projects, but we were doing just slightly different data sets in each of these projects. And we noticed that actually if we want circular economy to take off in the continent of Europe, which is our goal under the European Green Deal, then there needs to be, at least at the European level, a common language to speak in circularity. And that's when me, together with some colleagues, started a big European research and development project under the Horizon program to start developing this uniform nomenclature, which is applicable to all industries and to all European countries. And this project ran from 2013 to 2019. We developed approximately 500 passports at the product level and tested them on approximately 10 buildings to see, okay, now that the circularity data is available at the product level, does it actually help us to create more circular buildings? And after the project was done, let me skip. Oops, here's an example of what the dashboard looked like. This is one of the buildings. This is another one of the buildings, the Zollverein in Essen. And once the project was done, the Ministry of the Economy in Luxembourg took it upon themselves to go for an ISO certification of this international standard. So a lot of work has been done in the pre-competitive landscape to allow industries and the consulting network to start speaking the same language. And this ISO norm 59040 is part of the first family of ISO norms for the circular economy. There's now 5 in total, and this one in specific is focused on communicating circularity data at the materials and the product level. My invitation to all is to start using it, and also to feel free to approach me or my colleagues to help you understand how it works and to apply it. It sits under the no, excuse me, I need to take one step back. The digital product passport, as part of the ESPR, is also in the European Green Deal, meaning that all industries will have to share digital product passports with their products by 2030. We believe that this ISO norm can function as the backbone for that digital product passport. And yes, the digital product passport can have additional information that is relevant, specific for instance, textiles, or for instance, batteries, or consumer goods, or construction goods. But it's of crucial importance that the basis of all these data sets is one standardized format in one common language. And then to close off my presentation, I will give you an example of how we're already applying passports in projects. EPEA offers passports at the product level as well as at the building level. We use the name Circularity Passport for our format, and obviously we're basing our work also on these international standards that we've been co-developing in the pre-competitive domain. One of our most recent big projects that was opened last year is the World Trade Center in Brussels. Our role was twofold. We had, with our real estate consulting branch, we helped the owner of the building to meet the very high level cradle-to-cradle requirements of the tenant, which was in this case the Flemish government. And with EPEA Industry, we helped the supply chain to communicate circularity data and also to achieve cradle-to-cradle certification for the materials that were being used in the building. So circularity data at the product level was gathered and then shared into a circularity passport at the building level, which was presented to the building owner and also to the tenant, the Flemish government, who had this requirement as a very explicit requirement for the building. The building sits in the north part of Brussels. It's called ZIN, and it's the old World Trade Center that used to consist of two separate towers and is now one big building consisting of two towers that are joined together by this center piece that actually stretches all the way to the back to connect with the second tower. I believe my time is up now, so I'm going to hand the word back to the organization.
Thank you so much, Hein. We have plenty of questions in the Q&A, some of which have already been answered. I'll try to answer the ones that haven't been answered in writing yet. So maybe start with my colleague Ferdinand, and he's asking Hein, what similarities and differences between cradle-to-cradle certification and LCA studies are there?
Yeah, that's a good question. So, and actually, the Dutch government asked us the same question about 10 years ago, and we published a paper that explains LCA in the context of cradle to cradle or vice versa, depending on how you look at it. But what it comes down to is that LCA is primarily a tool that focuses on environmental impacts and provides an incentive to industries to reduce those impacts. And cradle to cradle, in essence, is a framework to integrate positive impacts into buildings, products, and systems. And the way it can support each other is, of course, that LCA is a nice calculation method to see if your optimization and innovation work has resulted in certain environmental gains. Unfortunately, what we sometimes also see is that under the cradle-to-cradle framework, we want to radically change a certain type of material, product, or building, whereas LCA is a little bit more focused on improving the existing. And so sometimes there's a bit of a conflict in the two approaches.
So the following question will address this as well, asking if there is a requirement for LCA in C2C certification.
Yeah, especially under the version 4.1, which is the most recent version of the cradle-to-cradle standard. There's a recognition of LCA as a way to report performance under certain evaluation criteria. Yeah, so we're very actively looking, because we know that that LCA is very broadly used, and obviously you don't want to reinvent the wheel. So wherever information is available and usable for certification purposes for cradle-to-cradle, we definitely want to recognize that.
And as you're already on, I will address the final question to you. It's in the circularity category. Is recycled and bio-based content used interchangeably, or is there a rating for recyclability, like in Recyclers, for example?
No. Well, they're not used interchangeably. That's a dangerous word to use. Obviously, those are two very separate things, right? So to manage materials into technical flows or to manage them into biological cycles, that requires very different approaches. So no, they're not interchangeably. But yes, in the sense that there are certain performance metrics that are comparable in order to create a level playing field for all types of products, materials, and systems. So, and sorry, Duzica, but basically under cradle-to-cradle, we see the potential, obviously, that was also displayed by Martin and Sergei in their presentations, of using more bio-based materials, especially in the sense of carbon banking, material health, and all of those topics. But at the same time, we don't want to shut out any synthetic materials or conventional materials, but those will have to go through their own process of improvement towards cradle-to-cradle goals.
You obviously try to combine them in your efforts, so this is great. I will address the next question to Sergei. Do you see an example of housing construction that uses hemp in Thailand or Southeast Asia, where the climate is more humid? Is there any observed issue there?
Yeah, it's a good question. Thank you very much. Yeah, this is basically what we are trying to resolve right now. Oops, sorry. Yeah, this is what we are trying to investigate. So far, we haven't seen any problems because the problem is of course people there in those regions, they never used concrete products before the Western culture introduced them to such technologies, and now we see mold everywhere on the buildings due to the high humidity and the high density of concrete. So using bio-based, very light materials, lime-based products that are highly alkaline is definitely a way to move forward. So we have a couple of projects that we're working on right now, and I think by the end of the year, we haven't built anything in Thailand. We have done a couple of workshops, but we have a couple of projects in the pipeline, and I think, yeah, I think it's a necessity rather than a consideration to use such technologies as hemp lime. Yeah, so I don't see any problems. We have also a project in Bali, Indonesia, where we would be combining bamboo. Bamboo is stronger than steel in tensile strength, stronger than concrete in compressive strength if it's treated properly. So yeah, I'm very sad to see that these countries are building with concrete where they could be using bamboo, for example, that grows in 4 or 5 years, that can be harvested and treated properly and used as a load-bearing elements, as well as hemp lime. Yeah.
I will also address the next two questions to you and combine them. As for hemp-based construction materials, how do they address the stringent fire protection requirements for construction products stipulated by the regulations? And also when it comes to fire hazard, especially within the context of countries that still make use of open fire flame stoves, are there any issues?
Yeah, we have officially tested our material, for the fire resistance. So 15 centimeter thick, 1 meter by 2 meter samples were installed in a furnace, and it survived easily a 60-minute test. It was 800 degrees Celsius on one side of the, where the flames were exerted upon the sample, and the temperature in 1 hour never climbed above 70 degrees Celsius. So we also have tested our product in California about 4 years ago with one of the local fire departments, and they had a flare for a special test. This flare was 3,000 degree Fahrenheit, which is 1,700 degrees Celsius. That's when titanium begins to melt, and the material didn't burn through more than 2 centimeters. So can you imagine? I don't know what has to I don't know what has to happen, what kind of temperatures we're talking about here with wildfires, but I think 1,700 degrees Celsius is convincing enough. And that, believe it or not, this was unplastered material. So that means it was unprotected insulation material, meaning that if you would be, once you cover this material with some type of render or plaster, you create an extensive amount of protection. So meaning, prolonging. Don't forget, fires, like Martin said it correctly, people don't die burning down in fires. They die from inhaling toxic components the houses are built out of. So if you're using bio-based materials with zero off-gassing, that's what kind of hemp lime is. Then we're talking about protections for hours. So when we're doing testing of fire resistance, first of all, it should be oriented towards not how quickly material burns down or how toxic the fumes are of these materials. That's the priority number one. And unfortunately, again, a construction industry is always talking about the energy efficiency, always talking about the regulation, certification, testing, but they never talk about the health aspect. This is a very young topic that been just introduced, unfortunately. And I think it should have been introduced 100 years ago in the regulations, so.
We have plenty more questions regarding your hemp building efforts. Simon Schwarzwald from RedCert is asking, I've seen companies pushing the use of coconut fibers for purposes similar to those you described, with the additional benefit that coconut fibers are considered residues rather than somewhat recycling. Could you elaborate on the benefits of hemp in comparison to other bio-based products? And because it really does look promising in his perspective.
Well, we have used our lime-based binder with different types of biomass. So, of course, in some of the countries, for example, like Indonesia, in Bali, it's forbidden to grow industrial hemp. So we have to source a local biomass, for example, like coconut fiber or bamboo shredded fiber. Similar to the hemp herds. Hemp herds, what is so good about hemp is it is an incredibly light biomass. There are millions of air pockets inside one of these little chunks I was showing you on the photograph. So in terms of thermal performance, hemp is ideal, but we're not limited to using hemp. For example, our friends in Mexico, they're using coconut fiber as a filler with the lime-based binders. As well as, for example, in Costa Rica, another company, friends of ours, they use sugarcane waste, bagasse, as a filler with the lime-based binder. So whichever biomass is available in your region, that's the one you should be testing extensively with. So for example, rice husks is another one. I have seen companies use different products, whatever is available. For me, so far, what I have seen, hemp herds is the best in terms of thermal performance. But again, we don't need to drag this product halfway across the world in the container to build a bio-based material. Maybe for the as an initial prototype case, yeah, I agree with this. We need to kind of educate the world and the local building authorities along with architects and builders. But in the long run, it's not sustainable to bring stuff from Holland to New Zealand, for example, right?
Thank you. And two more for you, and then I would wrap it up. And if Hein could please leave for Marisol for your contacts in the chat, she would appreciate this. I think you gained a new client. So Sergey, when you say that the local sources of hemp are used for the Colorado stargazing camp, how far from the building are these grown and harvested? And also, do you have experience with perennial crops like miscanthus, for example, in comparison to hemp? And how would you see the potential of such materials?
Well, in terms of the distance of from the facility to the construction site, of course, you want to limit that distance, to lower the carbon emissions. For example, the facility that we're sourcing our hemp from is located a couple of 100 kilometers away from the building site, which is ideal. We don't want to see things, for example, like there are oaks growing in Ukraine. They take those oaks, they chop it down, and they bring it to European Union, where the French company is producing parquet floors, and then bring it back to Ukraine to sell it to Ukrainians for like 60 euros a square meter. So this is kind of defeats the purpose. So of course we're trying to be conscious about where we source our biomass, and just to kind of limit the distance. I mean, that's the powerful story about hemp, because hemp is a source for manufacturing thousands of different products, paper, textiles, biocomposite materials, construction materials, food grade products, medicine, and etc. It can go on forever. So it has an enormous opportunities, not just in the construction industry, but in many other industries. For example, like textile industry, highly toxic industry, cotton industry, incredibly toxic, full of pesticide industry, where hemp does not require any pesticides put into the ground. On the contrary, it's used for like soil remediation projects as well. Yeah.
Thank you very much. Martin chose to answer one of his questions in writing, but I think this might be interesting for others as well. So on the LCA database that he mentioned, you can find it on ecobout.de. He shared the link in the Q&A section. So
Sorry about the miscanthus. I
Yes.
forgot to answer that question. Yeah, miscanthus is a great biomass to use. Yeah, for example, hemp industry requires a lot of funding to get going at scale. So this equipment is quite expensive and sophisticated, and requires substantial amount of funding. So if you're already aware of the biomass that's been harvested and processed locally, that's great. So miscanthus is also a great way to start making different insulation materials, particle boards, etc.
So as we are already quite over time, maybe we should go to some questions related to Martin Behrens, and then close the webinar afterwards.
I think Martin answered most of his in writing in the Q&A. And this would leave us with a final invitation to join our next webinar on April 8th on digital tools developed to improve certification and consumer communication in the bio-based industries. We would like to thank all three speakers. Thank you for initiating the dialogue and also showing that we need to do quite a bit when it comes to certification of bio-based materials, but also the potential that they have. And also you will find the recording and the slides in the following days on the website of the 3Co project and BioReCer project. Thanks to everyone for joining, and hope to see you soon.